I want to talk about inequalities with addition and subtraction. What you'll notice when we solve inequalities is they are exact same as equations in terms of how you actually solve them, with one major difference in that there are infinite solutions as opposed to just one solution. So let's look at a very basic problem or very basic equation like x plus 3 equals 5. Well, as you know, we would subtract 3 from both sides to get x by itself. We'd say 5 minus 3 and x equals 2. 2 is the only number that if you plugged it back in for x, that it would make the equation true. So if you said 2 plus 3 equals 5, 2 plus 3 is 5, and you would say, yes, 2 is the only number that added to 3 would equal 5. Well, if we make this into an inequality, we would have x plus 3 is greater than 5. Now, you solve it the same way. We want to get x by itself. To undo the operation, we subtract 3 from both sides. Now we have x is greater than 2. What that means is any number greater than 2 we could plug in for our graph and it would work. So what we actually plug into our equation and inequality and it would work. So what we actually do right here is this. We graph our inequalities by drawing a number line. We put arrows on the end because the number line goes on forever. I put the 0 as kind of a marker. I put my 2, and if it's just greater than or just less than, I draw an open, non-shaded circle, and then I'm going to graph to either the right or the left. This is everything greater than 2. Let me do that. Everything greater than 2, so I shade everything to the right. What that means is any number in this section greater than 2 would work. For instance, if I have 3, 3 plus 3 is 6, and 6 is greater than 5. If I plugged in 4, 4 plus 3 is 7, and 7 is greater than 5. Now, I like to have my students check. So the first check is this. I say take your original inequality and make it an equation. Say x plus 3 equals 5. Then take your answer 2 and plug it in for x. So I'm going to take it in red here, and I'm going to say 2 plus 3 equals 5. And we want the left side to equal the right side. So we, actually add these together, 5 equals 5. It means that 2 is good. Now we need to check to make sure that it should be greater than. So now again, I take my original inequality and take it over here. And I say, well, what we have is x plus 3 is greater than 5. Okay. I'm going to put plus 3 is greater than 5, and here's the key. I choose a number that's greater than 2, that's my answer, and I plug it in for x. So I'm going to choose 3. 3 plus 3 is 6. Oh, and 6 is greater than 5. What you notice is you could choose any number. Let's say instead of 3, I chose something else. Let's say I chose 10 because 10 is in my solution. 10 plus 3 is 13, and 13 is greater than 5. Now, just for the sake of showing you, if I chose a number anywhere over here, it would not work, such as 0. What if instead I wrote 0 plus 3? Well, 0 plus 3 is 3. 3 is not greater than 5. Again, so that's how you would check your work. Let's try another example. Let's go number 2. We'll say that x minus 4 is greater than or equal to negative 8. All right. The way we undo subtraction is we add 4 to both sides. Notice I'm working straight down the page right here, okay, because I always want to have my inequality in the middle. So that leaves me with x. I drop down my greater than or equal to, and I say negative 8 plus 4 is 4. This is my answer. We want to graph our answer, so we put the number line again with the 0 on 4. Since it's greater than or equal to, not only do we draw a circle, but we also shade it in to say that it could actually equal 4. Okay? This arrow is pointing to the right, so we graph it going to the right again. Again, what this means is any number greater than 4, if we plugged it into our solution, it would actually work and make the inequality true. So if I check my work, again, the first check is I take my original inequality and I make it an equation. So I say x minus 4 equals negative 8. I plug in my answer 4. right here. All right, 4 minus 4 equals negative 8. 4 minus 4 is 0. Oh no, you see that I made a mistake. 0 does not equal negative 8. So what I must have done is done something wrong. I'm going to go back. It was subtraction I should have added. It's negative 8 plus 4. Oops, it should be negative 4. There you can see the mistake. Yes, I made that on purpose to show you that how you check your work. So x is actually greater than or equal to negative 4. So what you'll see is this. My graph is now going to start down here at negative 4. I close it in, and it's going to shade, still shade, to the right. Now let's plug in my correct answer to see if it works. Negative 4. Negative 4 minus 4 is negative 8. And all of a sudden, you have a correct answer. Again, second check, what you want to do is you want to rewrite your inequality. So we'll say x minus 4 is greater than or equal to negative 8. Something minus 4 is greater than or equal to negative 8. We're going to choose a number that's greater than negative 4. If 0 falls in your solution, I'm going to go ahead and plug 0 in. 0 minus 4 is negative 4, and indeed, negative 4 is greater than or equal to negative 8. So I've checked it correctly. The only other thing I'll show you that you can see with inequalities is this. If you were given an inequality, I'm having trouble getting my color down here. Okay. If you're given an inequality such as negative 6 is greater than x, well, we'll say this. We'll try this. We'll say 8 plus x. You notice that my variable is on the right side. So my suggestion to my students is actually to swap sides. So you want to say 8 plus x is actually less than negative 6. The reason why we would say that is because if you have 5 is greater than 2, and you wanted to swap the 2 and the 5, and you said 2 and 5, this would have to change to less than. So if we change the sides right here, the symbol has to change. Very quickly, this is positive 8, so we want to subtract 8 from both sides. We have x is less than negative 6 minus 8 is negative 14. We'll graph our answer, which starts at negative 14. It's less than, so it's an open circle, and it shades to the left. And there you have it. There's a quick snapshot of how you add and subtract inequalities. The last thing I'll mention is there are a few key words that you want to get down, such as the words at most and at least. And you want to understand not more than and not less than. The analogy I always give is to students is this. At most you could make a 100 on your test. At most, that's the top, it's the maximum. It means less than or equal. You could make 100, but you can make less. At least, if I told students you need to at least do 10 homework problems, at least do 10, okay, well you could do 10, so it could be equal to 10, or it could be greater than 10. So at least means greater than or equal to. For not more than, it's not more than that, it's less than that. And could it equal that? Sure. If I said not more than 10 problems, well, you'd say less than 10 problems. You could still do 10. Not less than will be greater than or equal to. If I said no less than 3 students should come to my class after school, no less than 3 means that 3 could come, or you could have more than 3. That's obviously greater than or equal to. That's all I have for you.